Alright, in this part of the video, part 3, we're going to start with problem 6 on the review. This is the part that deals with symmetry. So part 6 asks you to locate the intercepts, indicate whether it's symmetric with respect to the x-axis, y-axis, or origin. Now later on, the y-axis symmetry is going to be called an even function, and the origin symmetry is going to be called an odd function. X-axis symmetry, when you have that, not necessarily going to be a function, so it doesn't have a relationship with functions. Alright, let's look at these examples. 33, it looks like you have two x-intercepts at 1, 0 and negative 1, 0. It has x-axis symmetry because this part down here folds it down to this part. So does this. It has y-axis symmetry because it folds this way across the y-axis, and it has origin symmetry because when we rotate 180 degrees it matches up. So it has all three types of symmetry. 34 has no symmetry. It only has one y-intercept at 0, 1. You can't fold it either on the x-axis, y-axis, or rotate it around the origin to have graphs match up. 35 has x-intercepts at pi over 2, 0, and negative pi over 2, 0, y-intercept at 0, 1. It has y-axis symmetry. You can fold right here. It doesn't have x-axis symmetry, and it doesn't have origin symmetry. 36 has y-axis symmetry. No on the x-axis, no on the origin. So just y-axis symmetry. It has the intercepts at 2, 0, negative 2, 0, and 0, negative 3. 37 has intercept at 0, 0. That's an x-intercept and a y-intercept. It has x-axis symmetry, no on the y-axis symmetry, and no on the origin. 38 has all three types of symmetry: x-axis, which is this way, x-axis symmetry, y-axis symmetry, and origin symmetry. If we take it, rotate it around that dot, we're still going to get the same circle. The intercepts are 2, 0, 0, 2, negative 2, 0, and 0, negative 2. 39 and 40 are cubic graphs, x to the third graphs, just by the way they look like. They both have origin symmetry. They don't have x-axis or y-axis. They have three x-intercepts on each of them, and they have one y-intercept at the origin for both. So those are those graphs. All right, on problems 41 through 44, it asks you to complete the thing based upon the axis of symmetry that you want here. So in this case, we want y-axis symmetry, so this one's going to be folded along the line. Folded along this line right here. Y-axis symmetry is going to be folded along this line on the y-axis. Oops, that didn't go the right way. Okay, let's try again. So we're going to fold along this line along the y-axis. So when we do so, we're going to get that line over here that looks like this. Looks something like that. Y-axis symmetry. X-axis symmetry, it looks very similar, but we're going to fold along the x-axis. So on this one, we're going to fold along this line here. So on this problem, it's going to go this way. All of the x values stay the same, but the y values change to the opposite. So this would be 5, negative 3 down here. On the on the y-axis one back here, the x values change, so this is going to be -2, -5 over here. Alright, origin symmetry means that we're going to rotate it, so this one's going to come around and rotate so that it looks like this on origin symmetry. So this point goes there, this point rotates to here, this point rotates to there. Y-axis symmetry again on this one, so it's going to rotate around and look like a circle when done. So that's how we rotate on symmetry based upon what they gave us. Alright, next problems are going to be with inequalities. So they're going to ask you to look at a graph and write an inequality. So 15 here was given as a problem. We start at 0 here and end at 3. So the interval notation for that is bracket 0 because 0 is included, and 3 with parentheses because it's not included, just like it is there. We could also write that in inequality symbols as 0 is less than or equal to x is less than 3. So that's interval notation. This is inequality notation. And when we drop down to these problems, they want you to rewrite them in interval notation and write it on the number line. So they're going to ask you to do this part and this part. Okay, 23. We'll do a few of these. 23 is an interval. So it starts at 0 and ends at 4. So we have brackets here from 0 to 4 because of them being equal. On 25, we have a bracket on 4, but it doesn't end at 6. It ends before 6. So it's going to be a bracket at 4 and ending at 6, but parentheses there. So we match it up like that. Okay, now the number lines, when we graph these, would be the same type of graph. So we'd have a graphing a line. We'd have 0 on one end, 4 on the other. These would be brackets. So it would look similar to the graph, and it's everything in between. So it's going to be shaded in between. This one, same thing. You have your number line. You're going to go from 4 to 6. So 2, 4, 6. So we're going to go from 4 to 6 on this one. It includes 4, bracket there, parentheses here, fill it in. Now in some books, this will be an open circle and this will be a closed circle. Will be those both closed circles in that one. Alright, 27. It's greater than or equal to 4, so that means we start at 4, but we go to infinity. We're going up forever, so we go 4 to infinity, not including infinity, because there is no example for infinity. There is no number, so we don't use a closed bracket. 29, it's less than -4, so that means it's lower than -4, so we have to start at -4 on this side of the bracket. It's the highest value, and negative infinity would be where it would go down to. So this would be the interval notation there for that one. Graphs would look similar, except it'd have arrows on these brackets. So we'd have 0, we'd have 4, something like this. But the graph would go like this, start at 4 and go forever this direction. So we'd put an arrow there saying it goes forever in that direction, instead of having stopping at any point. Same thing goes on this one. We'd go backwards. Here's 0, here's -4, here's -8. We'd start at -4 with the bracket. We'd know we were going down, so we go this way with our arrow, and we'd shade everything on this side. Alright, now on the other ones here, they're giving you the interval. They're going to want you to write inequalities and draw the number lines. So we'll do the inequalities, but I'll have you just draw the you should be able to draw the pictures based upon the inequalities. So in 31, we're going from 2 to 5, so your inequality would be 2 less than or equal to x less than or equal to 5. This one's 4 or greater than 4, so it'd just be x is greater than or equal to 4. This one says between -2. These look like ordered pairs here, but since it does say it's interval notation, this is between -3 and -2, so it would be -2 less than x less than, I'm sorry, -3 less than x less than -2. And this one goes from -infinity up to -3, so that means x has to be less than -3. So those are the interval notations given and the inequality notations written. We would draw pictures similar down here for those. 31 would look like this. 32 or 33 would look similar to that. It would have open brackets on both of them. 35 would look like this one. Actually, 35 is this one. And 37 would look similar to this one, but it would start with a -3 here. All right, let's move on to the next problem, which is finding out whether functions are functions of x, if y is a function of x. So to determine y as a function of x, what we would be looking for is that for every x, you'd only get one y value. So we're looking at basically every function that's going to be okay here is except for a square root. If we have y, when we solve it, y equals plus or minus a square root of value, then that means we'll have two values for y. So that's not a function, because it gives you two values of y for each value of x. So this one's okay. This one is yes, because there's no plus or, we wouldn't take the square root here. We wouldn't need to. It's y equals already. This one's yes. It has a function of x. This one would be no. 31 is no, because it's y squared equals 4 minus x squared. And in order to solve it, we would have y equals, and we'd have to take the square root. And when doing so, we would get this, and we would have two answers for y. Same problem here. This would be no also, because we need to take the square root to get y. This one's okay. This one's yes. And this one would be no, because you'd have to do the same thing there. To solve for y, you'd have to get a square root. So when I'm solving this one, it would be 3y squared equals 1 minus 2x squared, because the first step would be to subtract the 2x. We divide by 3, so it'd be 1/3 minus 2/3 x squared. Divide by 3, and then you'd have to take the square root. So you'd have that plus or minus square root of this problem, which would give us two answers, a plus and a minus answer. So that would be no. All right, and then the next part of this asks you to determine whether represents a function from a standpoint of just looking at points, and that's the same thing. We're looking at when values of x gives us two answers. So we only have a -1, a 2, and a 4, so this would be yes. Okay, because -1 only goes to 0, 2 only goes to 3, 4 goes, that's a yes, it is a function. Okay, hopefully the next one will be a no, and this one is a no because of the 4 here. 4 is assigned two values. 4 is assigned to be -1 and 4 is assigned to be 2. So there's not a function here because there's two values, two answers for 4. So the domain on this one is the values -1, 2, and 4. The range is the values 0 and 3. Okay, similar here, domain is 4 and 2, range is -1, 1, and 2. And the last part here we're going to look at for this part of the thing is to look at a graph and see if it's a function. Well, you pass the vertical line test. Vertical line test. Vertical line test can only cross once. Crosses once. So this is a yes, and this is a no. right there. No. And that's the difference.